Yeah, his sister left the lights on.
What sister?
Alina?
Yeah, makes sense.
Today is 10, 12, 11. My gosh. I'm going to just leave that word sitting up there until you guys all write it down and promise me that you'll never misspell it. So
Parallel?
That's the
I only
word.
know how to spell it because one of my favorite songs is called Parallel.
Interesting.
Because I've learned how to spell it since the third grade.
Rad. The second, right. The trouble is sometimes people do it like this. So just, yes, there's still, yeah. So the double L's come first. The second word that we're going to vow to spell correctly is a little bit of a longer word. You might know it from some prior experiences that you've had in other math classes. I wrote that one out a little bit neater for you in case you're unfamiliar with the word. So today we'll be talking about parallel and perpendicular lines, and this is one of those interesting lessons where sometimes people don't understand it, I guess. It's like, it's weird. There's like a split. No one ever kind of is decent at this. You either will get it or you're just going to be completely lost. And it's, before I explain to you what's going on, let me just tell you this, that if you think it's difficult, you're not correct. Okay, you're making something harder than it needs to be. So we're going to first just talk a little bit about some basic geometry ideas, and then we'll tie that into algebra, and then I'll show you how to apply this. Okay, you guys have not taken a class yet called geometry, because in Algebra 1, this is a class that you take before geometry. So next year when you take geometry, you'll use these words a lot, like a lot. So first off, let's talk about parallel. What does it mean for two lines to be parallel? It means that they never cross. It also means that they're in the same plane, just FYI. And sometimes kids wonder, well, why is that important? You can have what are, I don't know if you can see whoever's on the recording won't be able to see this, but do you see how this line and this line would never touch?
Yeah.
But you would agree, can you see that they're not parallel? So that's why when you get to Mr. Manlove's class, he's going to make sure when you say the definition of parallel, you're going to say two lines that lie in the same plane and never intersect, right? So that's a good definition for Mr. Manlove. Bless you. The definition of parallel lines is two lines that lie in the same plane and never intersect, but that's not really what we need. I need something else. For algebra class, I need something else. So what is it that makes lines parallel? Like, I get that I should say it a different way so you don't answer the wrong way. What is it that makes lines never intersect?
Different coordinates.
Yeah, I mean, that's for sure. But think about it, like, and I saw like Peyton held up his arms right away. As soon as I said parallel, a lot of us do this, or we do this, or we do this. But and that's what we should be thinking is, what is it about those lines that makes them parallel?
But they're
Do better. You're so warm right now. You're on it.
trying to figure out the word.
It's a word that, who said that? Thank you. I was about to give you a hint and say it's a word we've said 1,800 times in the last 3 weeks. For lines to be parallel, they have to have the same slope. And you can let that simmer for a second until you're ready to agree, but it's a fact. If one line has a slope of like up 3, right 4, in order to be parallel to it, any little sister line that's going to fly right next to it like a train track has to go at the same rate, right? It has to also mimic and go up 3 and right 4. So in Mr. Manlove's class, he's going to want a much fancier definition of parallel lines. But we don't need that this year. What we need to know is that two lines, if they're parallel, have the same slope. That is our definition. So let me ask you a question. Are those two lines parallel?
No.
They are not. And you didn't fall for the 2/3, did you? Not you guys are too good. You're too smart for that. You get it. You looked at the slopes and said one of you goes up 2, right 3, one of you goes down 2, right 3. You're not going to be parallel, are you? So when we talk about lines being parallel, the number that's in front of x, the slope, is going to be the same for both equations, right? So if I wrote an equation like y equals 4x minus 19, could you write me the equation of a line that's parallel to it? I'll take anything.
Y equals negative 4x.
Nope. I want,
Four.
it's got to be 4x. And then you could put, yeah, you could put plus 4. You could have put plus 4,297.6. Repeating. I don't care. The point is, we go back to what Josh said. If the lines have the same slope, enough said. We agree. So that's going to be our carrying definition for parallel lines, is that to be parallel, you have to have the same slope as the other guy. We're not interested in the y-intercepts at all. We want the slopes to be the same. We good there? Okay, let's talk about the other word, the longer word, perpendicular. And does anyone know what a definition is of perpendicular? And again, I don't need Mr. Manlove's fancy definition. I need just one that's going to get us by. This is a tough one. Yeah.
I'm not sure, but I'm guessing it's kind of like the opposite of parallel, like two lines that are crossing, but like never.
Yeah, it has something to do with lines crossing. I will say this for sure. So like, here's an example of lines that cross. Are they, and if you know the word, if you've ever seen the word, then you know that the answer, we already know the answer. Are those perpendicular? No, they're not. No, they cross, meet. But do you know what lines do when they're perpendicular to each other?
Make angle.
That's the one. They make a very specific set of angles. If I want two lines to be perpendicular to each other, when they intersect each other, they don't just intersect each other, they intersect at a very particular angle, and that is exactly 90 degrees. So that's really cool. But again, I would be forced to wonder, like, well, how does that apply to me? Like, we're right in the middle of a unit on writing equations with x's and y's. What the heck does this mean for me? So I think that that side of it is more appropriate for next year. When you guys get to this, you guys can put your hands up and flex on Mr. Manlove and show him that I know what parallel means. I know what perpendicular means. For us, this is a harder one. If I told you that the slope of this line was, I don't know, let's say 2/3. That is a stretch. This is always a stretch. Anyone want to take just a shot, a stab at what the slope of the other line is? It's not, but it is definitely negative. What an excellent guess that was, by the way. But can we agree that the second line is steeper than the first line? So we know that 2/3 won't work. The first line was pretty rad because you can see that it had a tilt of up 2, but it had more sideways, didn't it? So that's why that line's a little bit flatter. So for the other line to be perpendicular to it, yes, it goes negative, but what else happens? Yes, you would. So for two lines to be perpendicular, their slopes are what we call, sorry for this, reciprocals. Have you guys heard that word before? It's what you call it in math when you flip a fraction over. And God, I hope that makes sense why one line has to be steeper than the other, right? To perpendicularize a flatter line, you have to be a steeper line, and vice versa. So that's going to be our definition. It's very loose, it's very casual, it's not very pretty, but our definition of perpendicular lines are lines that have opposite reciprocal slopes. Good. So let me give you an example of a couple of lines, and you tell me if you think they're perpendicular. Why not?
Yes.
Oh boy, one of them has to be negative, right? It's not enough. When we talk about opposite reciprocals, the reason I put two words on the board is because I need them both. Being reciprocals is not enough. One being positive, one being negative is not enough. It has to follow both rules. They have to flip and switch sides. So if I had wanted you to say yes, then I could have put a negative like on this 4/3, and then you would have said, yeah, those are perpendicular lines. So let's practice what, like I said, and then we'll get into it. Because once you understand what this all means, then the problems are actually really quick and easy. So I'm going to write an equation. Y equals 4x plus 58 in the fifth. There it is. Easy peasy. What I'd like you to do is write for me an equation of a line that is perpendicular to my line.
Y equals,
Goblins?
Negative 1/4.
Yes, it would. People sometimes say, you got to flip over a whole number. And my answer is, of course you can. The whole number is just 4/1. And Gobble's got it. If you flip it over, it goes to 1 and 4. And then you slap a negative on it, right? And then what would the y-intercept be? Negative 1/4 of x minus, say again?
86,000.
I like that. Beautiful. Okay, let's do it again. So I'm going to write you an equation, and you're going to help me write the equation of a line that's perpendicular to it. So I'm going to give you guys y equals negative 1/5 of x minus 24. Could you give me one, Cal, that is perpendicular to this?
Yeah, y equals positive 5 plus 62.
Love it. And you didn't say the x, but I filled it in for you.
Oh, yeah.
It's all good. So at this point, do you understand what I mean when I say parallel and perpendicular? Okay, then let's get to our examples, because once you understand, I feel like you guys kind of get that. So when you see the problems, I think you're going to be like, yeah, we can do this. So our first example, so all that was just kind of a warm up, is this. I want us to write the equation of a line that goes through this point, negative 6,5, and it has to be, the rule is it has to be parallel to the line y equals 1/2 of x minus 4. So I just will go back and say again to you what I said before. What does it mean for two lines to be parallel to each other?
Same slope.
That means it's perfect. It means they got the same slope. And what's the slope of the line I gave you? 1/2. So all I'm saying to you, and this, if I seem a little weird about this, it's because year after year, people struggle with this. If I want you to be parallel to this line, all I'm saying is, hey, yo, just steal the slope and use it. And guess what? Same as before now. Nothing changes. What would our equation be? Y minus 5 equals times, just like that. See it? That's the new thing. And you might wonder, like, why did that take 15 minutes to get through? It's because 28 years of trying this before have told me that we need to take time on that for you to really understand parallel and perpendicular. Today's all about the slope. I mean, I think about this. I could have put minus 4,921.08, and we would have given exactly 0 craps about this number, right? It doesn't matter. We came, we took the slope, said, thank you, sir, and then we did our problem. And I'm not going to waste your time by converting that to slope intercept, because that's what we're practicing right now. But that will be the expectation from now on. Yeah, man.
So both of them, both rely on slope.
Everything is all about the slope. Let's do another one. We're going to go through the point 4, negative 10, and we are going to be perpendicular. I'm going to start abbreviating that word to the line y equals 1/3 of x plus 156,928.4. Repeating, what the heck? So again, in code, I'm not asking you to do anything major here. I'm just asking you to crack the code. And the code is, what's my slope going to be? Well, okay, this line has a slope of 1/3.
Oh, yeah,
Noted. But I don't want that slope because I want to be perpendicular. So I steal his slope and then I mook around with it and I use it and I run. So what is my slope going to be? Negative 3. Like that. That's it. Take what's given, mess with it if necessary, don't if not necessary, and then do what we do. And again, let's just write the first version of the equation. We know we're practicing converting. I'm not going to take up notes time with that. So my equation would be y plus 10 equals what? -3 times this. Yes, it's all about going in, stealing the slope, and then deciding if you want to mess with it or not. Still good?
Yeah.
Okay, then I've got just a few more. And these ones also get missed every year. So you just have to make a choice. Is it going to be me or someone else? So we're going to go through the point -7, -3. And we are going to be parallel to the line x equals 4. Oh boy. Ah boy. What the heck just happened? So all this talk about slope. So this is a vertical line?
Horizontal. No.
It's a vertical line. So what do you want me to do? You want me to make another vertical line? I agree. X equals what? Nope. Done. Peyton walks up to me and shows me a vertical line and says, hey, my other hand's full. Could you make another line that's parallel to this? I'd be like, sure, man. I'd make another parallel one, another vertical one. And I just write the equation. And we know by now, vertical lines are x equals, and then an x is right there for the taking. Bam. All right, let's go again. These should be the easy ones, huh? Let's go 5, -8, and let's go perpendicular to the line y equals -12. What kind of line is that?
Horizontal line.
And what is perpendicular to horizontal?
Vertical.
So the answer is x equals 5. Good job. If the line I give you is horizontal and I ask you to make one perpendicular to it, the only way to go perpendicular or horizontal is to be vertical. And the only way to be vertical is to have an equation that says x equals a number. And the number is 5. Let's go again. The point is -6, 1. And let's go perpendicular to the line x equals -4. What kind of line is that? The purple one.
Vertical.
So the purple line is vertical.
Then
And how do I make one that's perpendicular to vertical?
Like
You make horizontal, and that's not very horizontal. Apologies, but I'm just going to leave it there for posterity. So it's a y equals, grab the 1. Any questions?
no.
So today's assignment is a practice worksheet. I had a few more examples, but I feel like you guys are good. So enough of me. I'm going to hand out the new worksheet and we're going to work. Sound good? All right.